stop and wonder how the device in your hand actually works? I mean, how a whole universe of color, sound, and information gets built from a language that only has two letters? Well, today, we're going to pull back that curtain on the digital brain. We're going to see how simple zeros and ones get turned into actual logic.
No, seriously, think about it for a second. When you tap on an app, how does your phone know what to do? It feels like magic, but it's not. The answer is this really beautiful logical process that all starts with the smallest possible piece of information. So yeah, let's start right there, at the very beginning. All right, to really get to the bottom of this, we have to start with the absolute foundation. We're talking about the most fundamental building block of all digital information. You can kind of think of it as the digital atom. And that little atom, it's called a bit. So a bit is the smallest unit of data in a computer, and it can only be one of two things, a 0 or a 1. That's it. Every single photo you take, every song you listen to, even this, it's all, at its very core, just a ridiculously long sequence of these zeros and ones. Okay, but why just 2 states? Why not 3 or 10? Well, it's all about reliability. It's the absolute most dependable way for a machine to understand information. I mean, think about a simple light switch. It's either on or it's off. There's no murky in between, right? Computers use that exact same idea. A high voltage can be a 1 and a low voltage can be a 0. It's just simple, clear, and totally unmistakable for the machine. All right, so we've got these bits, our little digital atoms, but where do they actually live inside your phone or your computer? I mean, what does it even mean to physically store a 0 or a 1? Let's dig in. Turns out, bits have 3 main homes inside our devices. We're talking RAM, hard disks, and the newer SSDs. And what's wild is that each one uses a totally different physical trick to hold on to that information. First up is RAM. This is your computer's super fast short-term memory. It's what's handling all the apps you have open right now. In RAM, a bit is just a tiny little electrical charge. It's held in something called a capacitor. So if that capacitor is charged up, that's a 1. If it's empty, you got it, it's a 0. Now for long-term storage, you've got the classic hard disk drive. You can kind of picture it like a record player, but for data. It's got these spinning platters, and on those platters, tiny microscopic areas get magnetized. So if a spot's magnetic field points north, we call that a 1. If it points south, it's a 0. And then there's what you'll find in most modern computers, a solid-state drive, or SSD. Since there are no moving parts, these things are way, way faster. An SSD stores a bit in a really clever way. It uses a special kind of transistor to literally trap electrons in a tiny, insulated little room. So if there are electrons trapped inside, that's a 1. If the room is empty, that's a 0. Okay, so we know what bits are, and we know where they live. But, just storing data is only half the battle, right? How does a computer take all those stored bits and actually think with them? How does it make decisions? Now, this is where things get really, really cool. The answer to all of that is something called a logic gate. And a logic gate is basically a tiny electronic circuit that acts like a miniature decision maker. It takes in some binary inputs, zeros and ones, applies one very specific rule to them, and then spits out a single binary output. This is the most basic, fundamental piece of how a computer thinks. And get this, these gates aren't just some abstract idea on a whiteboard. They are very real, physical things. At their core, they're built from billions, and I mean billions, of microscopic electronic switches called transistors. And by flipping on and off, these tiny transistors control the flow of electricity, and that's how they bring the rules of logic to life. All the amazing, complex stuff a modern computer can do, it all boils down to just 3 basic types of logic gates. Honestly, you can think of them as the 3 essential employees running the whole show inside the digital brain. So let's meet the team. First up, we've got the AND gate. I like to call this one the strict one. Imagine a bouncer at a super exclusive club. He needs to see your ticket and your ID. If you only have one or you have neither, sorry, you're not getting in. The AND gate is just like that. Its output is 1 only if both of its inputs are also 1. And you can see exactly how this works right here. That chart is called a truth table, and it's basically a cheat sheet for all the gate's possible decisions. Just look down the rows. If input X is 0 and input Y is 0, the output's a 0. If one is 1 and the other's 0, still a 0. See? It's only in that very last row, when both X and Y are 1, that you finally get a 1 as the output.
Okay, next up is the OR gate. I call this one the flexible one because it's way more forgiving. Think about being told you have to either clean your room or take out the trash. As long as you do at least one of those things, you're good to go. The OR gate works just like that. It spits out a 1 if at least one of its inputs is a 1.
And here's its truth table. You can see right away how much more chilled out it is than the AND gate. Look, the only way you get a 0 for an output is if both inputs are 0. In every other case, if either input X or input Y is a 1, the output is a 1. See, much easier to get a yes from this one.
And finally, we have the simplest employee on the payroll, the NOT gate. I call it the opposite one. It has only one input, and its entire job is to just flip or invert whatever you give it. You give it a 0, it gives you back a 1. You give it a 1, it gives you back a 0. I mean, it's so simple. Its truth table only has 2 lines. Input 0, output 1. Input 1, output 0. Done. But now, here's the really mind-blowing part. By combining just these 3 simple rules, and, or, and not, in huge, complex networks, computers can do any calculation you can imagine. We're talking everything from simple math to rendering a massive photorealistic video game. Every single one of those actions is just a long chain of these tiny little decisions. Okay, I know this might all seem a little abstract and technical, but the truth is you interact with the results of these logic gates every single day, probably without even realizing it. So let's bring this all back down to earth. Ever think about your car's seatbelt warning? That annoying little light only turns on if the key is in the ignition and the seatbelt is not buckled. See? That's an AND gate and a NOT gate working together. Or when you log into anything online, you need the correct username and the correct password. That's an AND gate. Even a smart thermostat that kicks on the heat if the temperature is below a certain point, or you tell it to from your phone, that's all built on these basic ideas. They are literally the invisible decision makers running our modern world.
So let's just recap. We went from a simple physical thing, like an electrical charge or a magnetic field, to a bit. From bits, we built logic gates. And from those simple gates, we've built this entire world of incredibly complex computation. And that leaves us with a pretty deep question to chew on, doesn't it? If every single complex decision can ultimately be broken down into simple rules applied to just zeros and ones, what does that really mean for the future of intelligence itself?